Hi guys, in this video I'm just going to be introducing the idea of what a differential equation is and also what it means to have a solution of a differential equation. So very simply, a differential equation is just some sort of equation that includes a function and its derivatives. So it could be like its first derivative or its second derivative, or it could get quite complicated. Well, you guys have already seen differential equations to start with. So, a really simple differential equation might say that dy by dx equals 2x squared. And we've looked at these and we know how to solve these. We would integrate both sides and we would say that y equals 2 over 3 x cubed plus c. So that would be a solution to that differential equation. So that's a really simple differential equation. When we look at more complicated differential equations, it's not quite that straightforward to solve. So for example, we might have dy by dx equals x squared divided by y. Now that's harder because we can't just integrate both sides in order to get our solution for what y is equal to. And it's particularly hard because there's some sort of, if y is a function of x, then these two things are interrelated, these two things are interrelated, and these two things are interrelated in a way as well. So, there's no simple way of solving this. But over the next couple of weeks, we are going to be learning some techniques for doing this, which are really important. And one of the reasons it's important is because differential equations crop up in all sorts of real-world scenarios. Like, for example, I'll give you a bit of a physics example, since I'm sure you're all physics nuts. We've got a spring with some sort of mass on the end, which I'm going to call m. Now, if you look at a spring, the force of a spring, the spring exerts on a body, is actually equal to a constant called k multiplied by how far you've stretched the spring. So if I then say that the mass is starting at this position and we're going to pull that mass down by some value x, then the force due to the spring is equal to kx. Now you guys know that force is also equal to mass times acceleration. So F equals ma. Now if the mass and the acceleration of this body are determined by the force due to this spring, then ma is going to equal k multiplied by x, and acceleration is just the second derivative of position, or displacement. So this is actually equal to mass times d squared x dt squared equals k multiplied by x. So what we've got here is that we've got the second derivative of x, and we've got x itself on this side, and these two are linked by some sort of equation. So this is an example of a differential equation in real life that can be solved, and that has a really real-world application. Okay, so when we say solved, what do we actually mean by a solution? Well, let's look at an example. I'll just bring that down. So let's say that dy by dx is equal to 2xy. Now I can't just go and straight up integrate that because we've got an x and a y in here, so that's not going to be very easy to do. But what if I said to you, let's just say that y equals e to the power of x squared is a solution, how would we check that that's a solution? Well, what we would do is we would simply take the derivative of this, which is the left-hand side of the equation, and see if it's equal to the right-hand side. So the left-hand side is dy by dx, which, according to our solution, is d by dx of e to the x squared. And the derivative of e to the x squared is going to be 2x, so it's the derivative of the power multiplied by e to the x squared. And then let's just check that the right-hand side is the same thing, 2x times y. Let's substitute in our value of y. Well, that's e to the power of x squared. And so these two things are equal. So that's actually equal to the left-hand side. So yes, that is a solution. It's a solution because if we imagine that this is the function for y, and we substitute it into the differential equation, we have to take the derivative along the way, but if we substitute it back in, it all works out. The left-hand side and the right-hand side are equal, so that differential equation is true. Now, as it turns out, in this particular case, y equal to any number, so we could call that c, any number to the power of e to the, multiplied by e to the x squared will actually be a solution. And we can verify that. We can say, you know, the left-hand side is dy, or dy by, that should be x, dy by dx. And if we take the derivative, that will actually come out to 2c x e to the x squared. And the right-hand side will be 2x multiplied by c e to the x squared, which is the same thing as the left-hand side. So, in fact, we have a whole family of solutions here that actually satisfy that differential equation. So, how do we know what the value of c is? Well, the short answer is we don't. They're all solutions. But we can find a particular solution. So we might say, if, let's say, if a particular solution, so this up here is a general solution, if a particular solution passes through, let's say, 0, 3, that means that when x equals 0, y equals 3 for that particular solution. So that means that going by our general solution up here, 3 is equal to c times e to the 0 squared. Well, e to the 0 squared is just going to be e to the 0, which is 1. So that means that c is going to equal 3. So that means that this particular solution is that y equals 3 multiplied by e to the x squared. So this one in the red box is our particular solution. Okay, so just to summarize, differential equations are equations that involve the derivative, but they can get complicated because we can have x's and y's all in there. An example of that is, mass on a spring. And what we can do is there are ways of finding solutions. We don't necessarily need to know what those methods are yet. We are going to learn about them. But for now, and for the exercise you're about to do, you'll be given potential solutions. in order to check that they're a solution, you might need to take the derivative and substitute into the left-hand side and the right-hand side. There may be general solutions that can be written in terms of constants like C. If we want a particular solution, we need to know something about a particular case. So in this example, it was when x equals 0, y equals 3. But you might get questions where, if x equals 10, y equals 2, or something like that. So if we want to find a particular solution, we need to know some more information. We should be able to substitute that in and find out what the constant is, and that will give us our particular solution. Okay, I hope that makes sense, and thank you for watching.